The big impact of the dislodged Falcon 9 booster that flew to the moon. Have you ever wondered what will happen to objects that get lost or displaced in space? Yes, a very curious mind will ask. Rocket boosters and pieces that come loose from spacecraft are some examples of the type of things that orbit around the Earth at high speeds. If the object is in orbit around the Earth, eventually the orbit will decay and the object will return to Earth and may burn up upon re-entry into the atmosphere. In such a manner, a Falcon 9 booster that was part of SpaceX's first deep space mission designed to monitor solar storms and Earth's climate will crash into the moon. How huge is this booster? What'll happen to the moon after the collision? What'll be the fate of humanity? Welcome to your favorite channel, Unlimited SpaceX. Don't forget to subscribe and hit the notification bell for more exciting news about SpaceX projects and Elon Musk's many controversies. How will a SpaceX property crash into the moon on Elon Musk and SpaceX's watch? They've always boasted about being the best private aerospace organization. This video will shed light on the big impact of the dislodged Falcon 9 booster that flew to the moon. Don't forget to subscribe to this channel and feel free to let us know what you think in the comments sections. Now let's get on with the video. SpaceX Falcon 9 is a two-stage rocket designed from the ground up by the American company for the reliable and cost-efficient transport of satellites and SpaceX's Dragon spacecraft. A SpaceX booster is a reusable rocket booster used on the Falcon 9 and Falcon Heavy orbital launch vehicles. In 2015, Elon Musk's SpaceX launched a Falcon 9 booster from Florida's Cape Canaveral Air Force Station. The rocket was on a mission to send the Deep Space Climate Observatory discover on a million-mile trek to Lagrange Point 1, a gravitationally stable spot about 930,000 miles, 1.5 million kilometers from Earth in the sunward direction. After the Falcon 9 completed a long burn of its engines and sent the NOAA's Deep Space Climate Observatory on its way to the Lagrange point, after that, the Falcon 9's second stage lost control because of two things. 1. The Falcon 9 booster did not have enough fuel to return to Earth's atmosphere. 2. The SpaceX booster also lacked the energy to escape the gravity of the Earth-Moon system. Since it lost control, the Falcon 9 booster has been following a somewhat chaotic orbit since February 2015. As it stands, the American company will reach the surface of the moon a bit ahead of the originally planned schedule. Elon Musk's SpaceX, in partnership with NASA, in providing the landing system for the first crewed touchdown of NASA's Artemis lunar exploration program, a milestone that the agency hopes to achieve in 2025. But with the latest observation, that won't be the first SpaceX property that'll be landing or getting in contact with the lunar system #1 citizen. Satellite trackers have calculated that the upper stage of the SpaceX Falcon 9 rocket will slam into the moon on the 4th of March 2022. The scientists were led by Bill Gray, who runs Project Pluto, a company that supplies software to professional and amateur astronomers. The American aerospace company usually disposes of Falcon 9 upper stages after launch by sending them back into Earth's atmosphere for a fiery death. We've seen SpaceX regularly land and reuse the first stages of its Falcon 9 and Falcon Heavy rockets. The company actually failed, as they were yet to pull off a first-stage touchdown at the time of the Discover launch. They achieved their first success in December 2015. It won't be long before we'll hear about the collision. After the Falcon 9 sent Discover to its proposed destination, the upper stage of the rocket went so high that it didn't have enough fuel to return to its home planet, Earth. Its time in orbit is now nearly up. The collision will occur on the lunar far side at about 4.93 degrees north latitude and 233.2 degrees east longitude. Analysis of data has revealed that the collision will occur by 7:25 a.m. Eastern Standard Time. In his comment about the coming impact, Bill Gray said that at a guess, the above prediction may be wrong by a degree or 2 minutes from the predicted time. He analyzed the difficulty in modeling precisely how sunlight pressure moves a tumbling, cylindrical object such as a rocket stage. He also said that they will be needed, and he's confident that he'll get more observations in early February to refine the prediction. That'll bring the uncertainty down greatly. Now you know what's going on and what'll happen in the near future. As much as we're looking forward to this event, we won't see the impact from here. How is that even possible if the collision is happening on the moon's far side? Crazy as it sounds, the moon's far side is so much different than its near side, which we'll see in the night sky. Tracking down its time and location is still important, potentially allowing moon-orbiting spacecraft such as NASA's Lunar Reconnaissance Orbiter, LRO, and India's Chandrayaan-2 to study the resulting crater. We may be lucky to have the image of the impact. Gray, in his interview with Timothy Bella of the Washington Post, said that his software complained about the event because it couldn't project the orbit past March 4th. This observation wasn't only made by Bill Gray. An astronomer and satellite tracker Jonathan McDowell of the Harvard-Smithsonian Center for Astrophysics in Cambridge wrote via Twitter, "For those asking, yes, an old Falcon 9 second stage left in high orbit in 2015 is going to hit the moon on March 4th. It's interesting, but not a big deal." He added in another tweet that objects left in cislunar orbit are unstable, will eventually either hit the moon or the Earth and get perturbed to solar orbit. Cislunar refers to the region between the Earth and the moon. It also suggested that when the Falcon 9 booster finally collides with the moon at roughly 5,771 miles per hour, it will explode on impact. In his conversation with BBC, he said, "It's basically a 4-ton empty metal tank with a rocket engine on the back." And so if you imagine throwing that at a rock at 5,000 miles an hour, it's not going to be happy. The speculated March 4th collision will be the first example of a regolith unplanned disassembly if orbital dynamics hold true. SpaceX principal integration engineer John Insterbucker said via Twitter. He even used the RUD acronym that Musk often uses to describe the destruction, or rapid unplanned disassembly, of a rocket during testing here on Earth. Innsbrucker, who hosts many of SpaceX's launch webcasts, clarified in a subsequent tweet that the March 4th impact will be the first lunar RUD for the company, not the first one overall. This is evident as many spacecraft have slammed into the moon unintentionally over the years, such as Israel's Beresheet probe and the Chandrayaan-2 lander both crashed during their lunar touchdown attempts in 2019. This collision isn't a planned one by Elon Musk and SpaceX, so scientists aren't expecting to learn anything new about the moon, though the outcome of the collision and the aftermath may be studied. There might be additional space debris after the collision, and it can have serious consequences. The consequences can be fatal because of the high speed that objects travel in space, which has been estimated to be around 5 miles per second. A collision with even a tiny chip of free-floating paint can damage a spacecraft. You would have seen this in sci-fi movies where a speedster collides with something and his or her trajectory changes. It also happens with extremely fast-moving cars. A tiny mistake can make the car skid off its track. In November 2021, there was a little disorder in the International Space Station as astronauts were forced to shelter in their spacecraft when they passed through a debris cloud from a Russian anti-satellite test. Space debris, or dislodged spaceship orbiting freely in space, can complicate future space travel. Based on previous moon collisions, we don't think the March 4th collision will change the lunar system. In 2009, NASA intentionally crashed the upper stage of the Atlas V rocket that launched LRO into a crater at the moon's south pole. The moon didn't change its operating procedure, nor did it move away from its orbit, though NASA got significant information about lunar geography. Also in 2014, NASA's LADEE moon probe crashed into the lunar surface. The agency reported that the impact probably vaporized parts of the couch-sized spacecraft and heated the probe to hundreds of degrees.